Hello, everybody. Mm, this is discolored, but this is my note cup. Um, just cold milk in there, full fat. So this is your astronomer from Helsinki. Thank you for joining me. We will be doing part 9, a short part to do flat field correction on the science images of the night and some other frames. And first is first. So I'm experimenting, really having fun experimenting with different features of the Zoom meeting. Um, I really get excited because being this YouTube creator launched me into um, a space where I always wanted to do but never had time to do during the PhD, basically to develop my tech skills. And I'm developing so many tech skills. It's amazing. Microphones, know how to do videos, um, web development, social media. So that's great programming. So I'm excited to finally a little bit get more tech expertise. It is so some pearls of wisdom. One of the pearls of wisdom from my dad that stayed with me is that he encouraged us to be his children tech literate. So he encouraged, even though we are females in astronomy, sorry, not in astronomy, in Armenia, didn't he still encouraged us to develop our tech skills? So I appreciate that, and he has done a lot for me to be quite advanced in using technology. So I appreciate that a lot, and I'm trying to also impart to my children to have tech skills. All right. So what have I done? I found some backgrounds for the whole Zoom meeting, which is the fish, and for my own screen, it's a blur plus an image of a book because I'm also an author. I now have 2 published books at least because I from this year, let's say, because I published before, but 2 published books from this year. They are both on Amazon, and one of them is Helsinki and Me, and this is the pink cover, a little bit of it in my background. So you can check out and support me if you want by purchasing my book. So and I hope for your enjoyment. The ebook is quite affordable. All right. Um, oh yeah, and I also did personal lighting and I'm forgetting the name, but personal touch up. So I think what it does is taking smoothing my skin and taking mm, the wrinkles out a little bit. But it doesn't take the white hair, so I'm less older, but still the white hair is there. So anyway, it's just for fun. I'm not trying to look scissors that way, but I'm trying to learn the software. So, um, and now we are doing a split screen in terms of using 2 computers because IRAF graphic interface is working on my MacBook, not on my iMac. But my technology is getting old. I hope that I will get new computer soon because things are getting old. All right, I'm gonna share my screen and we start. Today is the 20th room. Topic video tutorial part 9. We are gonna apply flat field correction to the science images. So thank you God so much for this time and focus to work on this project. Please help me to do a good job because I'm after all working for you. And I'm very excited to work on this project because it is my own baby project. So I'm curious about it. Um, Also, it has a lot of responsibility because I'm the one who pushes it forward and I don't really have funding. But nonetheless, I'm hopeful. I'm steering my ship in this case and trying to finish it to the best of my abilities as my circumstances give me time. What we are doing today, we will apply the normalized master flat to the science images. The documentation is this is the classical documentation. We are gonna check after each step to make sure that the reduction steps are working as expected. So we will open before and after in DS9 to compare. And we are gonna, I put here for myself to take screenshots, put it in green or something. But it's good, highlighted in green. And record the steps in the research notes. So let's review the aim of the project and the past steps. The aim of this project is to reduce and analyze spectroscopy data from the NOTE telescope. It is an open science tutorial where I hope to demystify science project work to the general public. What did we do last time? We created a normalized flat, master flat for the night. Maybe I put it here. Our normalized flat, master flat name is this. File name is normalized master flat. This is the name. And just the description, it is it 3.9? I don't remember which section it is. I'm gonna delete it. So chapter 3. This is a typical signal processing technical step. We are operating on a science images with a normalized master flat, and the operation is division. So you can think of image uh, as also an array matrix of the image, the 2D image as a matrix. Yes. So in a simple way, I like formula. Sometimes formula illustrates better than just words. Sometimes the other way for me. But basically, what we are gonna do, we are gonna take the image that we have and we are gonna divide it by the flat in order to correct our flat fielding. So the image after is equal to image before divided by the flat field image. So the first step is to create a list of images, and I have done that, but I will take you through the steps. Uh, so these images have to have been processed through bias and trim steps. So they have to have the BT at the end. And this is a way with the ls command that we use, the ls command in order to make a list in IRAF. But it is actually a bash command. And then I manually delete the unnecessary files. I'll show you how I did that. So I'm gonna stop sharing here and I'm gonna start sharing on my um, iMac, no, MacBook. All right. All right, here you go. So have many, many different files, right? They're starting to accumulate in my directory. You have to make sure you have enough space actually. So trying to open it. These are also files of the night, but I have to make sure that I open the ones, compile a list of the ones that have been, this is right. Okay, I see. Because I might divide it like, okay. So this column, the second column are mm, the second column are the files that need to be taken through the flat correction steps. So all of them have the BT at the end. And here I put what they actually represent. I'm gonna process the helium near arcs. The standard star exposure, and the science targets. Okay, yes. And I have three science targets for tonight. And these have been somehow processed prior to the flat correction because we have done a lot on them already. I want the X1 here. I don't want. So what I did, because when you operate on the flat image, I don't want it to be um, uh, kind of lost. I create a copy. So I preserve the previous step intact. That's how I do it. So in case the flattening doesn't work well or I make a mistake, then I still have the previous step image in order to do it again. That's why I do an I'm copy step. But here I'm just trying to rename this to be all right. I can take the X1 off, but it's all right. I was trying to rename the files so they don't have this gobbledygook LJI, which is a code used by the node telescope. I wanted it to make kind of sense what those images represent. And maybe I don't need this X1, but it's all right. Let it be. Also to make it shorter. So once I copied them, so I created the list of uh, the files, I labeled them, and then copied them with imcopy. And so that I don't overwrite them, and the new name should have the F representing the fact that they will be flattened. So I work from home and I share my home with my husband, so there are some noises. So these were the files, and in Sublime, for each file I gave the copy command. This is the original name. This is the new name, and a description of what it is. And then I processed in IRAF. With cat command, the copy um, script. So these are also new files that have been created. And then in iRaf now I made a list of those uh, files to be flattened. And you might think, why are you doing this? Okay, you can write a procedure however you want to do. I do it in a way that I can check. So at each step I can check. I double check a lot my work in order to prevent. So I could have done it with 1 or 2 lines of code, but I did it step by step so that I can check and see what's happening. But you can always optimize. So it's up to you how later you decide to do. And then I page through the new file, and this is the list of um, and maybe right check paging through the 62 flat gives me the list of all frames which will be flat field corrected. So these are all of the frames that will be corrected with flat field. It's all of the Hillenian arc frames, all of the quasar images, and all of and the single standard star of the night. I have only one standard star image. Okay, and this is where I stopped. Now, the next step is to actually do the flat field correction operation. Since we are using the master flat file, I have to be in KP and oscillate package, and I am. This is a KP and oscillate. And I will just double check again. EPAR KP and oscillate to make sure that dispersion axis for the wavelengths is 2. And then exit. Clear means to clear away, and maybe I can put this as tip. Clear task. Clears the screen from previous commands on the exit term window in iRaf window. All right. And maybe I can take this and put it somewhere in the bottom. Okay. So I'm in KP Noslit. I can put this one also somewhere in the bottom here. And here we basically run CCD proc, CCD processing step, and this time to flat correct the flat fielding effect. And now we have to make sure that we correctly put the images you do add 60 to flat. Why 60? Why add? What add does? It shows that it is a file. 6C, I number my code files so that I can see them all. Anytime I write code, I number them. The next code file I write is 7, the next one 8. So I have them in sequence. This is how I do it. For example, I don't have here another example, but maybe in another So I like numbering things, my code files. Okay, the output, we don't put anything, so it means whatever file name for the frame you put, the it will be changed. So there's not going to be a new file name. That's why I already pre-labeled them with F because they're going to be flat corrected. CCD type nothing, 0, no. So this time we don't do overscan, no. We don't do trim, no. This doesn't concern us. Flat correction is yes. And then all of these are no, these are correct, but we don't need them. So now for the flat field images, we have to put our master flat. MF0915 underscore res. We just copy it. Interactive. No, because we are not doing the overscan anymore. Copy this here. I'm just checking with my procedure just to make sure I didn't make some stupid mistake. All right. And now we can do go. What did I write here? Okay. And I forgot to write. This is what okay, so output says this file, the helium neon arc, uh, and then the flat field image was this, and the scale equals to what? All right, this is done. We're done. And now we check the before and after frames. Even put image. So this is our flat, the normalized master flat. And let's say we had QSO 103 BT. And this is QSO 103 BTF. So when you took this image and divide it by this, you get this. Looks bad, but it is corrected. It looks bad here, but it looks, it is corrected for flat field. We can try and look how, for example, the standard star looks like. The standard star was the 50, and the corrected standard star BTF is here. So let's take a picture. This is the corrected, flat field corrected one. And I will now populate with picture. Okay, I will stop sharing here. We're done with MacBook, and I will quickly my iMac. All right, we finished this step. We inspected the before and after frames, and let's take our images on the right is the flat field corrected standard star frame. Okay, I wanted to show you this, that you can also use one-liner in the in order to process the same thing instead of opening, and there are many ways of executing commands in IRAF. You can also write it out. So in this case, it was overscan no, trim no, versus CZD proc, but flat correction yes, and the flat, you should put your correct master flat name, and interactive no. And we did this. So just as a side note, repeating summary of what needs to be done so far besides images, what we have done actually with the by now. Besides images have been processed through IM combine, bias stream, and flat steps, flat correction with the master flat. Well, this is from a previous work. Okay, so now there's nothing at this point that needs to be written in a paper, and this is just a tip that you can use clear task in your XUterm window to clear it out. Is there anything to update in the procedure? No. Highlight include what I've done. In orange, what needs to be done. So it's gonna be the next step. Step 10. Making bigger font size. Next step, research notes. We have them. Acknowledgements. I put acknowledgements Macy, but also this procedure is a bit modified from Macy's prescriptions for this type of data, um, which we published in Stone Adult 2021. And I also had extensive training with Daniela Bedoni, who I would like to acknowledge. So to publish this paper. And of course, my astronomy PhD courses at the University of Turku as well. What is the next step to do next? We know. How do we feel? Good. Clean up. Let's clean up. I have to leave this for the video. This is done. This is done. And then what else? Nothing else. No, this one we can also close. This I can close. All right. Thank you very much for your time today. God bless you. And have great productive week, rest of the week.